Ladies and gentlemen, hello and welcome to this edition of our global webinar series. Today you will hear a product launch retrospective of the last quarter of 2021, and actually this is also our last webinar for this year. My name is Alexander Nebel. I am Field Application Engineer in Europe, and I will moderate the webinar today. We are very pleased that you find the time to join our webinar. Presenter today is Samuel Accardo, our Senior Technical Marketing Engineer.
Thank you, Alex, and good morning, afternoon, everyone on the call. Thank you for joining us for our very last webinar for 2021. Today, we're going to be doing a product launch retrospective. So I guess just to begin to introduce myself, my name is Sam Accardo. I've been with KEMET for roughly around 4 years, and I cover the Northeastern Territory of the Americas. So that's roughly the Virginias up through Eastern Canada. Background. I graduated from Louisiana State University with a degree in electrical engineering and a degree in mass communication. I saw the list of attendees, and I know some of you already know me, and you already have my email address, but just to let you all know, coming in January, we will be using our YAGEO email addresses starting from probably around mid-January. So you could find my YAGEO email address on the screen now. Feel free to reach out to me in the future if you have any questions. So looking at our agenda today, over this last quarter and going through December, we've actually had 2 different product launches, or we'll have 2 product launches, and we have 2 extensions or changes to our products. So today we're going to talk about aluminum capacitors, one of which is KeMOD high voltage. This particular capacitor will be launched in the next week or 2. The A780 is a hybrid aluminum polymer technology, and we're going to be changing a feature about this particular component, so I will cover that. For our ceramic capacitors, our MilPerf 123 surface mountable devices are going to have a T-level extension, and I'll cover that within a few slides. And then finally, we've recently relaunched our first automotive grade chokes. And so I will cover what we call the SCR and the SCT-XV series automotive grade chokes. So starting with KeMOD technology, I guess it's important to introduce what KeMOD is. It's essentially a bank of electrolytic capacitors that's pre-built so that you do not actually have to build your own bank. And there's quite a few benefits to this, and I'll point them out as I go through the presentation. But the image on the left actually shows our original design for KeMOD. That particular design is used for automotive applications. Basically, the benefit for that type of design is going to be high ripple current, high capacitance. But we started thinking to ourselves, what about customers that need high current with high voltage? And so we've built what we call the KeMOD high voltage design. And so that's what we're going to cover today for the KeMOD section. Now, starting off, I want to give you a background about KeMOD itself and what that entails. So for the original KeMOD, we started off with our radials or our axials. They're basically the same type of design, can type aluminum electrolytic, and that's exactly what this capacitor is. This is the radial crown version of that part. Now, this particular design is an all welded design. So these parts can be used in higher altitude locations as well, but also due to their design, these are very high current rated parts. And over the last few months, we've actually done some additions to the parts. We've made them in surface mountable packages. These surface mountable packages have quite a few different benefits. First of all, they are surface mountable, which means the parts can go through reflow. They can be mounted in the vertical, which is the left-hand side image, or horizontally, which is the right-hand side image. And then, of course, since they're in a surface mountable package, this type of design can have pretty high vibration specs as well. And then we've taken those types of components and we've put them into KeMOD automotive version of this design. And this automotive grade design, as I mentioned earlier, is made for high capacitance or high current. So if you're a customer that's looking at an automotive grade design, you want a pre-built module, this is a great option for you. We're able to put quite a few of these in parallel for you, which is going to give you higher capacitance, higher currents. And of course, we do have data sheets available for this design, but we're more than happy to sit down with you and just talk to you, learn about your requirements, and maybe do a custom design as well. Now, we decided to go for the high voltage design, and we decided to use our press fit technology to go with the high voltage design. And I will go through that in a few slides to explain why. But just to let you know, we're using our ALF 70 and 80, which are 85 and 105 degrees C versions of those parts inside of our high voltage design. And so this particular design, it could, right now, the way that it's made, it's 4 different capacitors. There's going to be 2 in series, 2 in parallel, but we could do additional designs where we're maybe putting 4 in parallel if you're looking for high capacitance with the same type of design. So looking at the design itself, I mentioned earlier that we're using the snap-in technologies. The reason for that is actually because it's very easy for us to put these types of banks together using this technology. So for those of you that are not familiar with the press fit, it's actually the same technology that's been using on transistors and other types of devices for many, many years. And KEMET, we were first to market for this type of design on a capacitor. And I believe we might still be one of the only manufacturers that has aluminum electrolytics with the press fit, but that's not necessarily a bad thing. And as I mentioned earlier, we're using this type of design in our module. And the reason being is because the press fit technology does not require soldering. So we're able to easily just snap them into the PCB. They're very secured in there. They make a great electrical connection. And then, of course, because they're not soldered to the board, they do not need to be washed. So it's a very easy manufacturing process for us. Now, the capacitor technology itself, it's roughly the same as snap-ins, and I'm sure most of you are familiar with the snap-ins. Basically, they have crooked little ends on them so that when you push them into the PCB, you could turn them over and solder them. Now, the types of capacitors, whenever I say capacitors, the type of can sizes, CVs, capacitances, and voltages, all of that is roughly the same throughout the technologies for the press fit and the snap-in. So it makes a lot more sense for us to just use the press fit technology. Now, looking at the key features and benefits here, some of these I'm going to cover more in detail on future slides. But to start here, it's basically a capacitor bank that's ready to be put directly into your application. So we've already chosen the capacitors, the voltages, the current, the capacitance values themselves to come up with data sheets on specific voltages and capacitances and current ratings. But like I mentioned earlier, if there's a custom design that you're looking for, we're more than happy to do that. Additionally, these are very easy to mount into the PCB. You can't really see it too well, but these little knobs here, these are actually for screws, and there would be M5 or M6 screws that you would just easily screw into the PCB. And that's something that we would actually get on a call with and talk to you about and lead you through that discussion on how to actually mount them. Additionally, there's polarity signs here where you could easily know which way to mount them. Electrolytic capacitors are polar capacitors, so they cannot see very high reverse biases. Additionally, there's a heat sink built directly onto this capacitor bank, and I'll touch on that on a future slide. Because these are using our press fit technology, they do have very long life for electrolytic capacitors. They have 18 hours at 85 degrees C at its rated voltages and rated currents. So with the derating rule, you go from 18 hours or 18,000 hours at 85. When you drop that down to 75, you're looking at roughly 35,000 or 36,000 hours. And then again, if you drop it another 10 degrees C to 65, we're looking at 72,000 hours. And that's again at rated ripple voltage or rated voltage and rated ripple current. So that's very good features for this type of component. And because they're using our press fit technology, which has pretty high ripple current capabilities, most of the pre-selected pre-built boxes that we have or modules that we have are going to have current ratings of around 20 amps. So these are good components to use in your design. And now I'm going to talk you through some of the benefits here or additional benefits. So one of them is the elimination of the balancing resistors. So essentially, if you're going to use electrolytics in series within a design, you're going to need to know quite a few things, and you're going to need to purchase additional components. So first of all, you're going to need to know how many electrolytics you're going to need to work with. You're going to need to know their rated voltages. And then you're going to need to know the bus that these parts are going to be connected to, and using that information and then dividing that information from the leakage current, you're actually going to come up with the value that you need for balancing resistors. The reason for the balancing resistors in electrolytics is when you put these parts in series, essentially what's going to happen is one of the capacitors can have higher voltage applied to it than another. And if you're operating these two parts close to I guess to their operating voltages, if that sways just a little bit, you might be applying more voltage to a part than its operating voltage. And that's something that we need to try to mitigate, one, for the life of the component. And then additionally, if you have one component that's constantly getting higher applied voltage, it's going to have lower life. And so the idea is to balance these parts using resistors in order to stop that from happening. And so first of all, our module has that pre-built in, so you don't have to worry about calculations. We do all the hard work for you. Additionally, the design itself looks kind of nice. So if you're designing something where you don't want a bank that looks like these images on the left-hand side, well, of course, we have an aesthetically pleasing device as well. Now, additionally, I mentioned that we have the built-in heat sink, and that's essentially what we have here. So a lot of customers tend to think that the end terminations of the part are actually what helps mostly with the internal heating of the part, but the internal heating is actually coming out of the top of the capacitors, or I guess technically the bottom, depending on how you look at it. But what I mean is the flat end of the capacitor itself. And due to an internal KEMET design, a lot of the heat is transferred to that top, which gives our parts high ripple current capabilities because there's less self-heating. Now we've added on this module to the top of the part, which essentially gives the part around, not around, but up to 15% more current capabilities than it would have been if we would have just put 4 standalone parts. And so that's a pretty decent amount of current capabilities from a part. Now, additionally, if you attach your own heat sink or cooling device to the top of this, you could actually get at least 50% more ripple current capabilities than you would have if you didn't attach anything to these parts at all. And so the design itself already comes giving you an advantage. So if you took one of our individual parts and looked at the ripple current capabilities and added that up, you would actually find that the pre-built module actually comes with more current capabilities than you would have gotten out of that design. So it's easy for you to mount in. It gives you an additional benefit. And then, of course, if you want to add on to that and add your own heat sink to the top of this, which you're more than welcome to do, you could actually get at least 50% more of that ripple current capability. Now, looking at our product offerings, right now we have these modules pre-built, but again, I mentioned this earlier, we're more than happy to look at a custom design for you. Just feel free to reach out to your local field application engineer. But looking at what we have available right now, we've selected values from anywhere from 700 to 1200 volts DC. And right now we have capacitance available from 560 to 1800 microfarads. Now, again, with a custom design, we could potentially get higher voltage ratings, and we could get higher capacitance values if we decided to parallel all of the parts instead of doing a series parallel combination. Right now, the module itself is 141.4 millimeters by 110 millimeters, and the height is roughly 96.1. On the chart on the left-hand side, you could see the voltage versus capacitance charts. I suspect over time, we're going to continuously add to this because this is something that we do at KEMET. We start off with base values, and then we add additionally to that. Now, moving on to the types of applications here, basically the main application for this particular high voltage design is going to be solar inverters and motor drives. Essentially, there's going to be a DC link capacitor built into those types of designs, and those capacitors are going to need very high voltage ratings. And so that's what we're focusing. Now, looking back at the older KeMOD design, I mentioned that those particular ones are made for automotive designs. And in particular, they could be used for inverters, DC link applications. Those are just higher capacitance, higher current rated designs. This particular one is rated for higher voltages. Now, the key takeaways here, number one, we reduced the number of components and actually the manufacturing requirements for you to put one of these into your design. So instead of designing in 4 capacitors, having to solder them in, having to balance them using balancing resistors, doing your own calculations, you get to very easily install these parts, and you could easier see these installing, I guess, screw locations on this picture. But essentially, it's a lot easier for you to design this in. And then, of course, we're able to get higher ripple current capabilities, and that's due to this additional heat sink up here, which will give you an additional 15%. Or if you put an additional heat sink on top of that, you could actually get at minimum 50% more ripple current capabilities out of the part. So that's just an overview of our KeMOD technology. At the end of this presentation, I'll be more than happy to answer any questions you have on that. Now, moving on to the A780. The A780 is not a new design. It's something that we've had for quite a few months now. We released this technology with another one of our technologies, which was the axial and the crown radial versions of this part. These types of parts are going to be the hybrid aluminum polymer technology. And so what that means is inside of a can, we actually have the polymer technology as well as the liquid electrolyte within the can. And that's kind of what you see right here in this, this image. Now, the benefits here. So whenever I compare a wet electrolytic to a polymer, the polymer has quite a few advantages that the wet doesn't. First of all, it's going to have lower ESR. It's going to have higher ripple current capabilities due to that. There's going to be no dry out for the can. There's going to be pretty high frequency characteristics. The device itself is going to have longer life. There's quite a few advantages for going to a polymer. Now, the one disadvantage, or the main disadvantage of going to a polymer, is that because the part lacks the electrolyte, which is a big part of the self-healing capabilities of a wet electrolytic capacitor, a polymer is going to have higher leakage current. And that's not a good thing for customers that have designs that are connected to batteries, because it will drain their batteries. So we came out with our hybrid design. It's not a new type of technology. Other manufacturers have this technology, but it's something fairly new to KEMET. This hybrid technology combines the benefits of the polymers, like the low ESR and high ripple current capabilities. By splashing in a little bit of electrolyte, we're also able to do very good self-healing. So what we're seeing here on this slide is the capabilities of our lumen hybrid polymer capacitors. So right now we have a capacitance range of 56 to 680 microfarads, and voltage ranges from 25 to 63. I know over time we're going to continuously expand that. We're going to give you additional ranges for capacitances and voltages, but since this is a fairly new technology for us, we have the values that are currently available. Now, this is an automotive grade design, so it can be used in automotive applications. And originally this part was rated for 3,000 hours. And that's the reason why we're including that in this particular presentation, because this quarter we're actually bumping that up to 4,000 hours at 125. So you're getting an extra 1,000 hours at that high temperature. And as you derate, the life is going to increase based off of that 4,000 hours as opposed to the 3,000 hours. So that is the big benefit here. And that's why we're introducing it. This particular component has an extension on its life, and we wanted to make sure that you are aware, because if you sat in on one of our previous webinars where we covered this technology, you might have noticed that it was a 3,000 hour life part, but it is now a 4,000 hour life part. And just a couple of other things, these parts do have fairly high ripple current capabilities. And again, that's due to its polymer structure. The polymer is much more conductive, and in turn, it's going to have lower ESR and in turn, higher ripple current capabilities. Because of the addition of the electrolyte in the can, one of the biggest benefits of using the hybrid is because of its low leakage current. And because of its design itself, they are very high vibration resistant, up to 30 Gs. You'll notice that throughout the rest of this presentation, we'll include a product brief. This product brief just kind of very quickly shows you what we have available. We're going to send out this presentation to all of you as attendees, or as engineers, or even customers, or even some of our distributors. So feel free to take this slide or this entire presentation. But this particular slide is something very nice that you could use in the future to very quickly take a look at and know exactly where our technology currently stands. So with that, I'll move on to the MilPerf 123. So very quickly, the MilPerf 123, it's actually available as a surface mountable device and a through-hole device, but today we're only going to be talking about this through-hole or the surface mountable technology. So the MilPerf 123 is actually a PME technology. A PME means precious metal electrode, which means we use silver palladium internal electrodes. Most capacitors today, especially in the commercial and automotive grade market, are going to be made with a BME technology, which is base metal electrode, which is going to be nickel or copper in the case of an RF capacitor. But for PME technologies, this is the older technology that has been around for many, many years, and it has a lot of benefits. This particular mil spec has been around for well over 25 years. It has a lot of field history, but the PME technology is something that has a lot of reliability, and it's something that a lot of customers, especially high reliability military space customers, are very much, I guess, keen on using, because that technology itself is something that is proven to be used and okay for those types of applications. Now, we have recently released the BME technology with the mil spec, and that's the MilPerf 32535, which has its own additional benefits, but the focus here today is on this PME. So what we've done here is we've actually released, or I guess the better word is extended, our MilPerf 123 offerings to include T-level for both the BP and BX versions of the part. And additionally, that's going to include additional options for CSAM screening for all of the QPL listed products. So if you are a high reliability customer and you're on this call, just note that we have extended the T-level screenings for the BP and the BX, as well as CSAM. Additionally, I've included the product brief here where you could see the different case sizes that we have available in both the BP and the BX dielectrics with their different voltage ratings and capacitance ranges. So again, this is a very easy slide for you to be able to print out, put on your desktop, and quickly see what we do have available. Now, moving on to our next product, this is a new release as well, just like our KeMOD. So I'm going to spend a little bit more time focusing on this technology. So the SCR and the SCT-XV are going to be KEMET's first automotive grade chokes. And I just want to give you a little bit of brief background history. KEMET has actually offered chokes for quite a few years. We acquired a company called NEC Token 4 to 5 years ago. And when we acquired that company, they became our magnetic sensors and actuators business unit. Now, the chokes that we have provided have all been commercial grade components. However, when customers would request automotive grade designs, we would work with them. We would come up with a design for them. And then, of course, we would get it PPAP and automotive grade compliant. So we're not new to having automotive grade chokes, but we're new to having a series or two developed specifically for automotive grade applications. And that's exactly what this particular set of components are. So looking at our portfolio of what we do have available, you can see for the AC line filters, we have both common mode and differential mode chokes. Obviously, those are the two main technologies here. The common mode choke is actually broken up into a few different types of technologies using a few different types of materials. We use either manganese zinc or nickel zinc for most of our ferrites. However, we are looking at nanocrystals, which will give additional benefits, but we're not going to cover that today. We also have something called the dual mode choke, which we currently have in commercial grade designs, but we'll have in automotive grade designs in the future. But essentially the dual mode design is basically where we take one common mode choke and two differential mode chokes and we combine them into one package. And that package is roughly the same size as maybe a common mode choke. So you're taking three components, making it into one component, and then coming up with a single solution. So we do have those data sheets available, but I do know that a lot of customers sometimes want to talk about their own designs because they're going to have their own common mode noise and their own differential mode noise that they have to mitigate. And so they do want to have conversations with us to maybe come up with their own custom designs as well. So the focus today is going to be the automotive grade components, which is the new release components from the KEMET standpoint. And that that's again going to be the SCR and the SCT-XVs. The difference is that the SCR is going to be using one type of ferrite material, while the SCT is going to be using a different one. And I'm going to cover that on a future slide. But essentially, the main difference here is that the SCT-XV is going to be a higher temperature version of the part. And additionally, we're going to be releasing the SCN-XV, which is going to be a dual mode choke in Q1 of 2022. So keep an eye out for that particular design. Now, first of all, I want to give you an idea of where these types of components are used. And I'm going to start off by using a non-automotive grade description. So basically, common mode chokes and differential mode chokes are used in conjunction with X and Y safety capacitors to build an EMI filter. So when you think of an EMI filter, imagine being inside of your home or office building. Now, everything that plugs into a wall is going to have an EMI filter. And whenever I say everything, I actually mean everything. If it doesn't, there's going to be some problems. So it could be your coffee pot, could be your laptop or your phone, which you're watching this presentation on right now. It could be your TV, refrigerator, washing machine, dryer. Everything that plugs into a wall is going to have an EMI filter. Now, there's a few reasons for that. First of all, the purpose of the EMI filter is to keep all of the junk or all of the noise that's coming from the AC lines from entering that device and causing some types of interference. Now, additionally, the devices that you have plugged in, such as my laptop right now, can be putting out noise as well. And we don't want that noise to get into the lines, because if you think about your house, for example, the electricity that's running to your refrigerator is the same electricity that's running to your TV. And so if your devices don't have an EMI filter, the noise that they're generating can also get back out on those lines and interfere with one another. And so the EMI filter has a two-port purpose on that. Now, additionally, it's used to protect against transients. So if you didn't have a EMI filter built onto into your refrigerator, for example, and lightning strikes your house, it's going to burn up that refrigerator. And then the same thing if you have an electric vehicle and it's plugged into your house. If there's not an EMI filter built into that, well, of course, the same thing could happen. And so it's built to use to handle transients as well. Now, since these particular series are used for automotive grade designs, we could kind of think of some of the applications that they could be used for. So we could actually see some of them here, but essentially what it comes down to is any type of power conversion inside of the vehicle, whether it's DC to DC or AC to DC, if it's running off of a motor, the types of components that you're going to see are probably going to include the safety capacitors and in turn chokes. So our SCR and SCT-XV components could be used in those designs. Now, I mentioned that I wanted to point out the differences in the ferrite materials. So we have essentially two different types of ferrite materials that are being used in these devices. The SCR is going to be using our S15H material, which is going to be our second highest permeability material that we offer. We chose this particular material in order to get the current, the inductance, the impedances that we were looking for our different components. Now, the SCT, which is the high temperature version of the part, is going to be using our 7HT, which is one of our high temperature ferrite materials. Now, there are a few benefits here for using high temperature materials. So first of all, the obvious one is going to be high temperature. So with a material like our S15H, that particular type of component is going to cap off around 120 degrees C, which means at 120 degrees C, once you go beyond that temperature, the impedance of the device, or in turn the permeability of the device, is going to drop off. Now, when it comes to the 7HT, those types of components can handle much higher temperatures. I believe up to around 180 degrees C right now, if I'm not mistaken. And so that type of component can maintain its permeability at those higher temperatures. Now, that's not the only thing. The 7HT actually can handle its permeability up to higher frequencies as well. So if you think about the frequency characteristics of the part, it can maintain its permeability over a higher frequency. So for example, if we chose our 7H material as opposed to our 7HT, at a certain frequency, that 7H material is going to start dropping off its permeability, while the 7HT is going to maintain that permeability. So right now we have quite a few different versions of the parts. We have 3 different core sizes. We have the 19, 25, and 29 millimeters, and they can be laid out in vertical or horizontal, and I'll go through some slides on each of those. We have a few different versions of the rated current based off of what we think our customers' requirements are going to be, but over time we'll continue to add to that, which gives us around 144 different part numbers available. And one thing I want to mention before I move on, we can do custom design. So if what you're looking for isn't currently available, feel free to reach out to your local field application engineer or product manager. We'll be more than happy to talk through this with you and come up with a custom design if it's something that we can mutually agree on. Now, looking at the selection guide, I mentioned right now, this is our first product offering for this particular part. So we do have the 3 different diameters, or 3 different core sizes, which are going to be the 19, 25, and 29. And you could just see the different inductances over current ratings that we have available. But again, we can work on custom designs, and I suspect over time we're going to continuously add on to this to give you guys more options for rated current and inductance. Now, looking at what the differences are between the designs themselves. So we have, starting with the SCR-19s, this is going to be the smaller core sized parts. We have the JV, V standing for vertical, and the JH, which is horizontal. If we look at the 2 components with their characteristics such as current, inductance, DCR, what you'll notice is for the most part, they're actually pretty much the exact same thing on what the capabilities are of what we can get out of the part. The big difference here is based off of what you as the end customer's requirements are. Do you have a lot of board space? And if you do, then we could put you with either of these types of components. If you're lacking on board space, then the small footprint or the JV, the vertical version of the part might be the best option. It's going to take up the smallest amount of footprint. Now, if you're a customer that has a very strict height restriction, then the horizontal design might be what you're looking for. So based on what your requirements are, we're going to have a different solution. Now, what you'll notice is with this SCR-19 and SCT-19, we have a very limited amount of windings. And the reason being is because we could only fit so many windings using the wire that we're using on this device, which gives us certain limitations on inductances. But as we increase the core size itself, we're able to get more windings onto the part. Again, you'll notice that the current, the inductance, and the DCR are roughly the same thing, but we're getting higher values for each of these. And that's because we could add more windings onto the part. And then, of course, as we move on to our largest core size, we're able to get even more windings, which means higher inductances, higher currents, and higher DCRs. Now, I want to point out here, because I didn't have a chance to go through this on a previous slide, is that these parts could actually get fairly high current ratings. So these parts could actually get up to 35 amps, and I'll go back one slide to show you the SCR and SCT-25s. These parts could actually get up to 35 amps of current. One thing I didn't mention as well is that these parts are actually capable of getting higher voltages as well. So all of these designs for automotive are going to be for 1000 volts, both AC and DC. So they are high voltage application devices. Now, I just kind of wanted to show you this slide to see where we're going in the future for choke technologies. I mentioned right now that we're using the S15H and the 7HT, which I can confirm now is 180 degrees C. The future of our technology is going to be higher temperatures with higher permeabilities. So we're looking at the 10HT as the future. It is currently under development, and hopefully within the next year or so, we'll be able to start offering components. The benefit here is we're able to give you higher temperatures, higher frequencies that these parts could work on. So the main purpose of an inductor within an EMI filter is to block the higher frequency AC currents while allowing the DC and the low AC currents to pass through. And so by allowing components that could handle those higher frequencies, we're able to keep that higher frequency noise out. And so the future is going to be higher permeabilities at higher temperatures, and hopefully at some point we'll be able to get high temperature versions of the S15H and the S18H as well. Now, just kind of want to go over some of the applications here. So again, these are automotive grade designs. What you see here is an automotive or essentially an EV, and what we have included is an onboard charger. This onboard charger is plugged into a house or a building or something like that, and it is going to convert the AC that's coming from those lines to a DC, and it's going to charge this high voltage battery. This high voltage battery is several hundred volts, so it's going to be very high voltage, which is part of the reason why our chokes are rated for 1,000 volts. And in some cases, in future designs, we'll actually be able to get up to 50 amps when we increase our core sizes. But looking at all of the different applications here, I'll just kind of start off with the first one. We have some of our lower voltage designs within automotive, and those are things like steering wheel, fan drives, compressors. Those are the types of components that are going to be using smaller chokes and smaller safety capacitors in their designs. Another thing is when we look at higher voltage, that higher voltage has to be converted to lower voltage. So the battery itself puts out 400 to 800 volts, and that is incredibly too high for a lot of the things within a vehicle, such as infotainment or some of the motors or connectors within a vehicle. That's way too high. So it has to be converted down using a DC to DC converter. And that DC DC converter is going to bring it down to 12 to 48 volts. Now, I mentioned earlier in my example, whenever I was talking about plugging into a wall, that's going to be AC. However, DC power supplies could also put out EMI as well, or put out noise. And so chokes could be used in those designs to mitigate that noise that's coming through. So they would be used for filtering. And in particular, the DC to DC converter within that design, or any electric vehicle design, is going to be used to lower the voltage for other types of applications within the vehicle to be able to use those lower voltages. So keep in mind that these components can be used for those applications as well. Additionally, these types of components could be used in smaller DC to DC converters as well. In this particular example, what we're seeing on the screen would be an electric water pump. The electric water pump could be using these types of filters. And again, that's because there could be some type of noise that's coming through from the DC to DC conversion. Now, the last one I want to talk about, I think, is a very important one, because there's a lot of designs that are going to be using or actually, when we talk about EV electric vehicles, all of them are going to be using onboard chargers. So you could think of an onboard charger as a regular AC to DC converter, kind of like what you would be using to plug in your laptop from the wall to charge it. So there's going to be an input stage, and that's going to be the EMI filter, where these types of chokes would be designed in conjunction with safety caps. There's going to be a power factor correction stage where you're going to see some switches. You're going to see some potentially snubber capacitors, some DC link caps, and that whole section is going to be converting that AC to a DC. Now, that DC can't be used at the voltage, or shouldn't be used at the voltage that it's been converted to, so it has to be converted to another voltage. So there's going to be maybe a resonant converter or LLC resonant converter that's built there, and that's going to be a DC to DC converter, where it's going to transform the voltage from that higher lower voltage to the voltage that it needs to be converted to. In this particular case, since it's the onboard charger, it's going to convert that voltage to a higher voltage in order to charge that battery to 400, 800 volts. And so these types of chokes can be used in a lot of different applications throughout the automotive market. I know onboard chargers is a big one that we're working on right now, and KEMET has a campaign for onboard chargers. So if you want to learn more about the different types of components that we have that would go in onboard chargers, including these chokes, feel free to reach out to your local sales rep or field application engineer. Everyone within the YAGEO group does have this presentation. Additionally, these types of chokes could be used in wireless chargers if that's something that you're working on. Again, the DC to DC converters as well. And again, we do have presentations that we could go through with you to talk about all of the different solutions that we'll have for those designs. And very briefly, I just wanted to go over the product brief that we have available for the SCR and the SCT-XVs. Again, it's kind of repeating what we saw for the MilPerf 123 and then the A780 aluminum hybrid capacitor. Basically, it just shows you what we currently have available technology-wise, the mounting options, whether it's vertical or horizontal. and then just kind of shows you some of the applications that these parts can be used in. And again, since these are chokes, they're used in everything from AC to DC power conversion. If it runs off a motor like a windshield wiper or oil pumps, electric heaters, if it's an electric compressor, all of these different types of applications can use these types of components. So keep this in mind that KEMET has released these new automotive grade series, and I could definitely tell you that there's more to come in the future. And with that, I'd like to wish everyone a Merry Christmas and a Happy New Year. This is our last presentation of the year. So with that, I'm more than happy to open it up for any questions.
Yes, thank you, Sam. Was
You're welcome.
An interesting presentation. And also to me, again, some good information regarding our new components of the last 3 months. So for now, I do not see questions coming up. So to the audience, you still have the option to ask us question now, either in the Q&A function or in the chat. And if you have questions later on, you can also contact your local sales representative or FAE, or you can contact Samuel directly or myself if you know my email address. So if there are no more questions, I would say thank you to everyone. And also next year we will continue with our webinars. As I can see again today, we have more than 100 people joining. So we can see a higher interest in our products. So please feel free also to enter your ideas into our survey you can have after this presentation. And then we can make a presentation according to your wishes. Samuel, seems like no question. This is a good sign. Everything is clear now.
Absolutely.
I would say
thank you, Alex.
for your time. Yes, thank you for your time today. And I hope to see you soon again next year.
Thank you. And thank you, everyone.
Okay, goodbye.
Thank you.